Okay, so for the very first problem, we have 4D plus 5D minus 6 plus 3D minus 4D and plus 5. So remember, terms, when we're identifying the terms are separated out by addition and subtraction signs. So my first term I have is that 4D. I'm going to draw a wall to show a barrier there. So I know I have a 4D, and I'm going to do my my semicolon. My next wall is drawn right here, so my next term is a positive 5D. So I'm just going to write 5D. My next term, I'm going to draw my wall right here, is a, since it says minus 6, when I look at it individually, it's like it's a negative 6. My next term is a positive 3D. My next term is a negative 4D. And then my last term is a positive 5. Okay, so I have 6 terms in all. 1, 2, 3, 4, 5, 6. Okay, my like terms, when we talk about like terms, we're talking about terms that have the same variable or they don't have a variable at all. So, same variable, my first set of like terms would be 4D. I'm going to put plus 5D because 5D was positive. All right, minus 6, is that a like term to it? No. What about positive 3D? Is that a like term to it? Yeah, so I'm going to put plus 3D. What about this negative 4D? Is that a like term to it? Yes, so I'm going to put minus 4D. What about this 5? Is that a like term? No, that's not a like term to them. So there's one set of like terms. So I used my 4D, my plus 5D, my plus 3D, and my minus 4D. Those were like terms. I also have another set of like terms, though. The ones I didn't use, that minus 6 and that plus 5, those are also a set of like terms. So I'm going to write that down in a different color. I have a negative 6 and a positive 5, a plus 5. Those are a set of like terms. So now the coefficient. Coefficient is relating to the number attached to the variable. So that's going to be the 4, the positive 5, the positive 3, and a negative 4. Those are my coefficients. Some of you got it wrong on your quiz because you included the variable. The variable is not a coefficient. It's a variable. So my coefficients are 4, 5, 3, and negative 4. Those are my coefficients. My constants are just the numbers, a negative 6 and a positive 5. Negative 6, positive 5. Okay? Now, simplifying your expression. The nice thing is that we already have our like terms set up, that we can go ahead and simplify them as they are. So if I were to take the 4D plus 5D plus 3D minus 4D, when I work all of this out, that's going to give me 8D. Then I've got my other set of like terms. I've got a negative 6 plus the 5. That negative 6 plus 5 comes out to a negative 1. So there's my final answer. And I'll write it all in one color so that you can see it. 8D minus 1. Okay? Let's take a look at the next problem. We have 5 minus 4x minus 8 plus 3 plus the 16x. Again, I want to build my walls around my terms. So 5 is my first term. What's my next term? Negative 4x. Good. My next term? Negative 8. Next term? Positive 3. Next term, positive 16x. Good. So I have how many terms? 5. We have 5 terms, right? 1, 2, 3, 4, 5 terms. All right, let's identify the like terms in here. So let's start with the variables, the variable like terms. What are my variable like terms? Brian? Uh-huh. Good. Negative 4x and that positive 16x. Those are my like terms for the variable that they have in common. That means everything else that does not have a variable, they are also like terms because they are called what again? What are they called if they don't have a variable? Constants. So we're going to list those down for our constants later, but we're going to put them here first. So we have 5. We have a negative 8, so it's like a minus 8. And we have a positive 3 or a plus 3. So there's a set of our like terms together too. Okay, the coefficients. The coefficients are just the numbers in front of the variables, not the variable itself. So that would be a negative 4 and a positive 16. Our constants are the ones that are numbers all by themselves, no variable attached. That would be the 5, the negative 8, and the positive 3. Okay, and if we simplify them, let's just take those like terms and simplify them down. What is negative 4x plus 16x? Positive 12. Good. Don't forget the x though, positive 12x. And then what do we get? We got positive 5 minus the 8 plus the 3. What does that come out to? 0. Do I have to write plus 0? No, so my final answer is just going to be 12x. Because I don't have to write plus 0 or minus 0. All right, my last problem, perimeter. We are combining the 3 sides together through addition. So what I'm going to do is I'm going to just focus on my like terms. So I've got a 7x on this side. Do I have any other like terms on my other sides that can be combined with a 7x? Angel? Okay, we've got a 15x. That can be combined. Anything else? Ashir? Negative 9x. That can be combined. So when I write those, I know I'm going to do 7x plus a negative 9x plus a 15x. Okay, I want to combine that together. 7 plus the negative 9 plus the 15. What is that going to come out to? Good. It comes out to a positive 13x. Okay, then we also have our numbers, our plain simple constants. What are our constants here? What's one of the constants? Anasia? Negative 5. Okay, that's one of our constants is a negative 5. What's another one, Ashley? Negative 8. So we can combine those together. We can do negative 5 plus a negative 8. What's negative 5 plus negative 8 going to give us? Negative 13. Good. So there's our final expression. We get 13x minus 13. That represents the perimeter of our shape. Okay, any questions? All right, go ahead and flip it on over to the back. We are going to discuss the opposite of our distributive property. So remember with distributive property, we are multiplying a value that's on the outside to each value that's on the inside of the parentheses. What we're going to do today is we're going to factor an expression, meaning that we're going to pull a common multiple, or not multiple, a common factor out from our terms as if we are undoing our distributive property. Are we good? Yeah? Okay. So if we take a look here, again, like I said, the concept of factoring is a process of undoing the distributive property. So we know with distributive property, we used to do, oh, we're going to do 5, and we're going to multiply it by 4x, and we're going to do 5, and we're going to multiply it by 7, okay? And that 5 times 4x is what gives us the 20x, and that 5 times the 7 is what gives us that 35. Okay, so that was distributive property. What I want to do now is if I'm given 20x plus 35, I want to know that I can take a 5 out from it, pull the 5 out by dividing. So instead of multiplying, we're finding what can we divide both of those numbers by. And we always want to focus on the largest common factor. the largest common factor that can go into all of the terms. Now, there's obviously several common factors that we can use in some problems, but we do like to, when we want to pull it and simplify and factor it as much as we can, that's when we focus on the largest ones. So if we're taking a look at a problem like 18x minus 24, I want to focus on the numbers that we have here, and I want to break them down into their factors. I want to pull them apart. So I'm going to highlight them and focus on them individually. Let's start with the 18. So when I'm focusing on the 18, my factors of 18 are going to be 1 times 18, right? What else? What are some other factors of 18? Angel? 2 times 9. Are there any other factors of 18? Amaya? 6 times 3 or 3 times 6? Okay, any others? Brian? Well, we already have 1 and 18, right? So I've already used 1 and 18, I've already used 2 and 9, I've already used 3 and 5. So the thing that is nice, if you go in order, go, okay, well I know that it can go 1 times 18. Okay, is 18 divisible by 2? Yeah, 2 times 9. What about 3? Okay, yeah, 3 times 6. What about 4? Can 4 go into 18? No. Right? 4 times 4 is 16. 4 times 5 is 20. We don't have an 18 in between there. So it can't be divisible by 4. Can it be divisible by 5? No. We know it would be divisible by 5 if it ended in a 5 or a 0. It's not going to do that. So then we're back to 6. Well, we already wrote 6. So here's a list of all the factors. 1 and 18, 2 and 9, 3 and 6. Now let's do the 24. So we're going to focus on just the number, not the sign. We're just focusing on the number of it. Let's identify our factors for 24. So again, we know 1 and 24. What about 2? Can 24 be divided by 2? 2 and what? 2 and 12. Good. What about 3? Can we do a 3? What? 3 and what? 3 and 8. What about a 4? Can we do 4? Yeah, what is it? 4 and 6. Can we do a 5? Nope. And then we're right back at 6. We already did a 6. Okay, because we had 6 times 4, 8 times 3, 12 times 2. So we have all of our possible factors. So what I want to do now is I want to identify what factors do they have in common other than the 1. So what factors do you see that they have in common other than a 1? Justin? Okay, 2, 3, right? They both have a 2. I'm going to put a box around my 2. So they both have a 2. What else do they have? And you said a 3, right? So I'm going to put a circle around my 3. They both have a 3. Anything else that they have in common? Natalia? They both have a 6. They both have a 6 in common. Okay? So I can factor out a 2. I could factor out a 3. I could factor out a 6. The largest one is the one I want to go with. So we're going to go ahead and factor out a 6. That means I'm going to do 6 on the outside. And then I need to know, what does 18 divided by 6 give me? And what does 24 divided by 6 give me? What is 18 divided by 6 going to give me? 3. So I now have 3x. We still have our minus sign. And what is 24 divided by 6 going to give me? What's 24 divided by 6, guys? 4. So we have a 4 here. This is us undistributing. We're factoring our problem out. That would be our final answer. And it makes sense, right? 6 times 3 is 18. 6 times 4 is the 24. Okay, so you're just undoing the distributive property and you're pulling out your largest factor. We want to focus on our largest factor, okay? Okay, let's go ahead and go over problem 21x plus the 14. We're going to identify each of the terms' factors. So we're going to split this apart and just identify what the factors are going to be. We're going to start with the 21. Who can tell me what were the factors for 21? Ashir? Okay, we have 3 times 7. Okay, and obviously we also had that 1 times 21. Any others than that? No, that's as much as we're going to get, right? Okay, what about the factors for the 14? Our factors for 14 were going to be what, Justin? 2 times 7. And of course, don't forget, you guys, your 1 and your 14. Okay, and those were it. That's the most factors that we had. So what were the common factors that they shared? Anasia? 7, right? We don't want to worry about the 1. The 1's an obvious. They all have a factor of 1. But we have the factor 7. So they both have a 7. And that happens to be the only factor that they have in common aside from the 1. So that means we're going to go ahead and factor out a 7. So if we factor out a 7, that means we're taking 21 and we're going to divide it by 7. And we're going to take the 14 and we're going to divide it by 7. So if I'm pulling the 7 out, what does the 21x now become? 3x, good. And then what does the positive 14 now become? A positive 2, right? A plus 2. And then there's our answer. We have 7 and then parentheses 3x plus 2. All right, so let's go ahead. It's no different even when we have 4. Even when we have 4 terms, it's 3 terms, it's exactly the same process, but this time we're going to focus on, 3 different termed values. So we'll have the 12 that we're going to focus on, we'll have the 4 that we're going to focus on, and I'm going to go ahead and highlight the 20 in a green since it's our 3rd term. I'm going to highlight that one in green, and we're just going to break those down. So we need to find the factors for 12. We need to find the factors for 4. And then now we have the additional term set. We have to find the factors for 20. Okay, so let's start with the factors of 12. We obviously have the 1 times 12. What else do we have here? What are some other factors for 12 going to be? What times what? Ashley? Okay, we've got a 3 times 4. Anything else that we've got? Diana? 2 times 6, right? And that happens to be it. Those are all of our factors for the 12. We've got 1 times 12, 2 times 6, 3 times 4. No other factors. What about my factors for 4 other than the 1 times 4? Obviously, 1 times 4 is an obvious. What else do we have? Natalia? 2 times 2. And then that's it. Those are all of our factors for right there. And then what about our factors for 20? Other than the 1 times 20, what else do we have, Justin?
2 times 10.
Okay, 2 times 10. And then there happens to be another set. Angel? 4 times 5. Very good. And those are all of our factors here. So let's identify the factors that we have in common. Obviously, we have a 1 in common. What else do we have in common? Ashley?
4.
We have a 4 in common, right? We all see that they have a 4. This one has a 4. This one has a 4. There's another one that they have in common, Brian. They both, or all 3 of them have a 2 as well. Okay, so those are our common factors. They both have a 2 and they have a 4. So which one am I going to use, the 2 or the 4? The 4, right? We want to use the largest one. We want to use our largest factor. So that means I'm going to take each of these terms and I'm going to divide it by 4. We're going to take each of those terms and divide them by 4 because we're pulling a 4 out. So when I pull a 4 out, what does the 12x become? 3x, good. 12x becomes a 3x. What does the 4y become? 1 y. Do I have to write the 1? No, I can write it if I want to, but it's not necessary. I can just leave it as a y. And then what does the 20 become? What's the 20 going to become? Brian? Not 10. Remember, we're doing 20 divided by 4. 20 divided by 4 is what? 5. Good, so we have a positive 5. Can you please stop playing with that? Okay, and then there's our final answer. We have 4, and then parentheses, we've got 3x plus 1y, or y plus 5. Okay? Everybody okay with the factoring? It's pretty easy. Yeah? So what we're going to do now is I'm going to have you guys log into Google Classroom. You're going to have 3 IXL skills that you're going to work on for today. Some of them remediating old skills and some of them practicing our new skills.